Here we go. Calculus of logarithmic functions. The derivative of natural log of x is 1 over x times the natural log of e. What's the natural log of e? That means e to what power is e? 1. So you get 1 over x. Derivative of natural log of x is 1 over x. If the base of the logarithm is not e, if it's not natural log, then it's just slightly different. It's 1 over x times the natural log of b. So, again, natural log of e is 1. That's why it just goes away, but natural log of b you would have to include. Flip it over. Let's take some derivatives. I will do this problem 2 different ways. I will first do it by using substitution. I'm sorry, the chain rule. And I have the natural log of u. What's on the inside? And I will call that x to the negative 2 power. What is the derivative of natural log of u? 1 over u. Good. 1 over u. Say 1 over u. Say 1 over u. 1 over u. All right. Derivative of x to the negative 2. So if we plug the x to the negative 2 in for u, we'll have 1 over x to the negative 2. What's 1 over x to the negative 2? X to the 2. So you'll have x squared over 1 times negative 2 over x cubed. What happens? X is canceling at negative 2 over x. Sweet. Not too bad, just a little chain rule, right? How about we make the problem easier? That's the answer. Would you like to make the problem easier? I'm going to rewrite natural log of 1 over x squared as natural log of x to the negative 2. Does anybody remember our properties of logarithms from last year? Oh, YouTube. Every single person said no, except Maddie says that she knows what to do, and she's correct. She is using these laws of logarithms right here, and this one says you can, if you have a logarithm of something to a power, you can take that power and move it out front. And so we are going to do that. Negative 2 natural log of x. Now, I haven't taken the derivative. I've just been rewriting it. So now I'll take the derivative. What's the derivative of natural log of x? 1 over x times negative 2. You'll get f prime is negative 2 over x. Well, that's pretty easy, isn't it? Derivative of natural log of x is 1 over x times negative 2 over x. Well, so Sarah and Maddie are now kind of asserting their autonomy and saying that they want to do it their way. And they're more than welcome to. But when we get to a more challenging problem, they would have to do the quotient rule with the chain rule twice. And if you use my way, you're going to work through a little bit more quickly. I'm going to do the same thing here. I'm going to rewrite this. F of x is, what can I move out front? 2x times the log base 4 of e. No, you don't have to have the parentheses. There's no addition inside there, but I just want you to keep your eye on that. If I said, what is the derivative of 2x, what would you say? You would say 2. If I said, what is the derivative of 2x times pi, what would the derivative be? 2 pi, right? That pi is just a constant. and it would just come along for the ride. This is just a constant. Log base 4 of e is just some number. How would we find it? Well, we take the log of e and divide by the log of 4 and see what we get. So this is just a number. So we get f prime of x is equal to 2 log base 4 of e. It is. Derivative of 2x is 2. This is a constant, so it just comes along for the ride. It's a multiplier, just like 2x pi. Derivative would be 2 pi. The whole year. And that would have been awesome, except it doesn't work unless you have logarithms. So thank you, Allie, for being the voice of reason. Kleenex is going up the nose. All right, so there we go. All right, letter C. What rule do I have to use? Quotient. Practice. Derivative of natural log. Times minus times what's the derivative of e to the x? Isn't that just fun to say? It's just like a good time all the way around. Hurt my feelings. Okay, e to the x squared. What's e to the x squared? We were all fine until you started talking, Adam. All right. If I factor an e to the x on the top, what's going to happen? Yep. So I get 1 over x minus natural log of x over e to the x. Can I leave my answer like that? Why? Fraction within a fraction. Thank you, Adam. You've redeemed yourself. And now we have a complex fraction. Okay? So I get 1 over x minus natural, or x natural log of x over e to the x. So I created a common denominator. And now I'll have x as a denominator. And if I multiply by the reciprocal, I get 1 minus x natural log of x over x e to the x. Yep. That's the instantaneous rate of change at any given point on the curve, natural log of x over e to the x. Yep. See my face with the Kleenex stuffed up my nose right now? Just have it like right here. Okay. All right. Okay. Right, I get that, but Darren makes a good point. We probably should do a face reveal. If we do, like right now, people have this vision of me that I'm really tall, really good looking, and really strong, and they think I have hair as well. And if we do a face reveal, they'll be just extremely disappointed. They'll start writing letters to my wife saying that they pity her. You know, I mean, I don't want that. I don't want that. All right. I'm going to rewrite this one. This you haven't seen yet. I have division. How can I rewrite division within a logarithm? I can write it as 2 logarithms with subtraction. Now what can I do? Move the exponents out. Have I taken the derivative yet? I haven't. Let's take the derivative. What rule would you use to find the derivative for natural log of 2x minus 3? Chain rule. Allie? I haven't taken the derivative yet. And the derivative is going to look like this. I have 4 natural log of u, and I have 2x minus 3. So derivative is 2. Derivative 4 natural log of u. 4 over u. 4 over u. 4 over u. 4 over u. See, it's fun. Come on, it's funny. All right, you say. Yeah, come on. Oh, you guys are boring. Okay. All right. When we multiply, we get 8 over 2x minus 3. Now, if we continue that kind of pattern, if you notice, the 4 is just a multiplier. All we had to do is take the derivative of the inside. What's the derivative of the inside here? 5 times the 6 will be 30 over 5x minus 1. So, if you want to make the boxes, that's fine. But after a while, hopefully you get good at taking the, the derivative using the chain rule rather quickly. No, you don't have to. You leave it like that. That's actually more helpful often than finding the common denominator. So let's leave it like that. Okay, letter E. Now, a lot of people would want to move the 1/2 out front, but I can't because log is being taken to the 1/2 power. So if it was natural log of 2x minus 1, just the inside of the 1/2 power, then I can move the 1/2 out. But look at the difference right here. Is the natural log being taken to the 4th? That's why we could move it out. But so in this situation, I set up the chain rule. And when I set it up, I say u to the 1/2. Good. 1 over 2 roots of u. Kelsey's on Q. And we have natural log of 2x minus 1. Yep, chain rule again. Thank goodness for a chain rule. Natural log of u, 2x minus 1. 2, 1 over u. Whoop, that's a 2. 2 over 2x minus 1. And then when we multiply those together, what's going to happen with the 2's? They're going to cancel. I get 1 over the 2x minus 1 times whatever, or the square root of u. Square root of natural log of 2x minus 1. That is your answer. Thank you. I think it's beautiful as well. Camera shot. Mic drop. Boom. All right, letter F. These are written as products. Hey, let's make life easier on ourselves. Instead of writing it as a product, we could separate it using addition. So I have log base 8 of x squared times plus log base 8 of sine of x. And I'm going to write this so that you understand it to the 4th power. That's what that means. So what should I do now? Put them out front. So f of x, so I still haven't taken the derivative. This is still the function, is equal to 2 log base 8 of x plus 4 log base 8 of sine of x. Now I take the derivative. Chain rule. Not for the first one. Derivative of log base 8 of x, well, that was on the front side. If it's not natural log, what do we do? It's just 1 over x, but you have to multiply the denominator by the natural log of the base. So, and I have the 2, so it'll be 2 over x, but then we have to multiply the bottom by the natural log of 8. plus D. Weiland said, let's use the chain rule here. So we're going to do that. We have 4 log base 8 of u, and then we have sine of x. Cosine of x. Close. 4 over u, natural log of 8. Stupid u. Oh, these are good times. Okay, so we get, when you multiply, you get 4 cosine of x in the numerator. In the denominator, you get sine of x times the natural log of 8. Oh, I have cosine of x over sine of x. Cotangent. So we have 4 cotangent of x over natural log of 8. Sweet. That's it. No, we got 2 more problems around the back. All right, let's try letter G. What rule do I use here? Quotient. F prime of x is derivative of the top. Derivative of 5 natural log of x. Just 5 over x, folks. Derivative of natural log of x is 1 over x. So, okay. All right, derivative of 3, 0 times 2 minus, well, not 2 minus, but 4 minus, hey. Okay, let's try this again. 4 minus 2 natural log of x minus derivative of the bottom. Derivative of 4, derivative of negative 2 natural log of x. Negative 2 over x. And so being it's, we'll make that plus 2 over x times the top. 5 natural log of x plus 3 all over the bottom squared. Amen, brother. Okay, can I leave my answer like that? Why? Yeah, I've got a compound fraction, complex fraction, right? So they have common denominators, don't they? They have common denominators of x, so this isn't going to be that bad. Not yet. What? They're both over x, right? Over x. And if I multiply by the reciprocal, the denominator will just, end up right here as well, right? So I have x times 4 minus 2 natural log of x quantity squared. If we distributed things in the top, are there some terms that would combine together? So that would make 20, and then that would make 6, right? 26. And then the 5 times a negative 2 natural log would be a negative 10 natural log. And 2 times a 5 natural log would be 10 natural log, so that would be 0. So we just got 26 in the numerator. That's it. So when we get back from getting some brain food, we'll cover problem G. And then I have a worksheet for you. And I don't have the answer key made yet. I'm going to be working on that today because I was grading college algebra tests last night. Okay, here we go.
So if we were to take this derivative right now, it would be pretty challenging because we have multiple product rules, don't we? I mean, you have the product rule a couple times. You have the chain rule as well. And so Allie said a great thing earlier. She said, why didn't we do this all year long? You know what I mean? Well, it's because we weren't doing logarithms, right? You don't have a logarithm here either, do you? So let's insert one. This is y equals right here. Let's do the natural log of both sides. So now I can expand this with addition. We'll raise x to the 1/2. Yeah, that's the idea. We technically don't distribute, but it's, you know, each piece that was written as a term being multiplied, we change that to then a logarithm being added. And now, what can we do? Yeah, put the exponents up front. So I have not taken the derivative yet. I still have the natural log of y on the left-hand side. What is the natural log of e? 1. Let's now take the derivative. I'm going to wait on the derivative of the left-hand side and focus on the right-hand side right now. Derivative of natural log of x. So it will be 1 over 2x. Yeah. Plus x. Right, and as we take this derivative, we need to use the chain rule. So we have 20 natural log of u, 2x plus 1. Derivative of 2x plus 1 is 2. 20 over u multiplied by 2, 40. Now look at the left-hand side. What do you think is the derivative of natural log of y? Got to attach y prime, right? Remember when you take the derivative of y? Like, I mean, remember when we did this? X squared plus 3y squared is equal to 9. You took that derivative. You said it's 2x plus 6y, y prime is equal to 0. Anytime you take the derivative of a y, you need to attach your y prime. Just like when we were doing implicit differentiation. So, I want to solve for y prime. So what will I do to both sides? So I have 1 over 2x plus x plus 40 over 2x plus 1 times y, which is the square root of x times e to the x times 2x plus 1 to the 20th power. That's it. Well, and the nice thing is it's already factored, isn't it? So looks pretty good. Another worksheet. So I have not made the answer keys yet. I was grading a college algebra test last night, but I will be making the answer keys during 5th hour today.